So we have another AMC 12 problem. So this was number 20, so which meant to be a bit challenging, but we'll see if this is going to be the case. So suppose that A and B are digit, not both are 9 or not 0. So just keep this in mind. And the repeating decimal 0.AB is expressed as a fraction in the lowest term. How many different denominators are possible? Okay, so we want to find the number of ways that we are going to get different denominators, right? So when you write this in fraction form. So if you're not sure how to deal with the repeating decimal, so it's kind of something we have to get better at that. So first things like we are going to do, let's say this number is going to be equal to x. X is a rational number when you write as a fraction. So that could be written as 0.AB, and then AB is repeating. So let me write this a bit better. So 0.AB, AB, AB, AB. So it will continue forever, but you cannot really deal with this immediately unless you cancel those repeating parts. So one way to get rid of this repeating part, just moving the decimal point in a way that we can actually align the repeating part. Since we have two digits are repeating, so if you move decimal point 2 places to the right and subtract the equations, you will see the cancellation. So that will continue forever. So if I multiply the x by 100, so you will get 100x. So if you multiply this number by 100, so you move decimal point 2 places to the right, so you will get AB, point by AB, 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 and it will continue forever. So the reason we just multiply by 100, so we can move decimal point 2 places. Why we do need to move this decimal point 2 places? Because the repeating digit, like there are two digit that is repeating. So when you have two digits are repeating, and then I just like to cancel those when I subtract. So if I just move it 2 places to the right, so it doesn't really matter how far you go. So you will cancel all the repeating parts when you subtract. That's the whole point. So this is going to be now subtracted. So 100 minus 1 will be 99x. And now you see all the ABs after decimal point will be gone. That will be 0, 0, 0. And then AB minus 0 is just AB. So then this is going to be AB point 0, 0, 0, 0, 0. That will continue forever. And if you divide both sides by 99, so the x is going to be AB over 99. So this is something we actually should really know already, but I just want to kind of remind anyway for those who don't really remember anything like that. So the number x is going to be AB divided by 99. AB is a two-digit number. So like whenever you have a two-digit number like that, and that is repeating, so you can just write this as AB divided by 9 immediately. So like say 23. If this is repeating, so this is equal to 23 over 99. So like if there is like 0.4, for example, so this is going to be 4 over 9 if you use the similar reasoning. But it's good to remember that when you have one repeating decimal, so then number itself divided by 9 is what you are going to get. But there are some other like a version of this, like you are going to probably explore those if you don't really know about them. But anyway, so let's move on. So for our question, the AB divided by 99, so the AB divided by 99, this is what we are trying to care. So since we are told both A and B can't be 9, so if both are 9, 99 over 99 should be equal to 1. But 99, if you want to write as prime factorization, that's 9 times 11, so which is 3 squared times 11. And the number of divisor of this guy, so one more, like when you find the common like number of divisors, you just add 1 to each exponent. So 2 plus 1 times 1 plus 1, which is going to be 6 divisors. 6 positive divisors. You can just list them if you want to, meaning that we do have at most 6 different numbers that we can have for the denominator, because if the numerator and denominator has some common divisor, we can cancel, but at most we can have 6 of them. So which is why we can immediately cancel these guys. So now the question is, if I choose A and B are 9, 99 over 99, which is going to be 1. So, but I cannot have both 9, so which is why we will have at most 5 like numbers. different denominators. So we'll see if this is achievable. And if you try, like, let's say the numerator has a divisor of 3, you can just kind of test those if you want to. But let's say the AB is like a number that just divisible by 3. So maybe AB is like 0, 3, because I can have A 0, B is 3, and then divide by 99. So if I do this, that will be 1 over 33. So the denominator is 33, which is one of the divisors if you want to list them. So like 1, 3, 9, 11, 33, and 99. These are the 6 divisors without really kind of listing. We already know that's the case, but so we cannot have 90, like if I have 90, like 0, 1 in the numerator, I mean 0, 1 in the numerator, so 0, 1 over 99, just 1 over 99, which means 99 is achievable. So we can say this could be a denominator, but as we've seen, the 1 can't be, because if I want to get 1 as the denominator, so the numerator has to be 99 as well, but that is not a law. So which is why we have at most 5. And you can test the other one as well, but I'm going to leave for you to test all of these, but I'm going to do one more, maybe one more. So if I want to get 33 as a denominator, right, we got that. That's already good one as well. If I want to get 11, so you should divide like top and by like bottom by 9. So you can say maybe like 18 over 99 or 9 over 99. So there are a lot of fractions you can have, but that is possible. So if I want to write, let's say 18 over 99, so A is 1, B is 8, so that should be 2 over 11. As you see, 11 is achievable as well. If you keep trying, so these guys are also achievable. So you have only 5 different denominators that is possible. So again, this is a number 20, which doesn't look like too challenging. But at the same time, when you really don't convert into this fraction form, it wasn't really like obvious how to attack this problem. So I hope that was clear. Okay, I'll see you in the next video.